continuing our discussion about congruent triangles. In this instance, in the last video we talked about the different ways we can prove two triangles congruence. In the previous video we talked about what triangle congruence really meant. Here what we're going to do is we're going to start with one of the theorems, and we're going to prove that said theorem using the postulate. So the idea was that we assumed that side angle side was a postulate, and here what we're going to do is we're going to assume angle side angle, and we're going to prove that it's true. So right now we're going on the assumption that it's not a theorem, it's an idea. It's something we want to show is true, and when we show it to be true, it becomes a theorem, and then we can reuse it without having to worry about that. And a lot of times what we do is we set one of these up in such a way that it makes it easy to prove. So what I did here is I actually created a triangle. I actually put two triangles back to back, so they actually share a side. And I did that because it's going to make it easy to prove that angle side angle works. So what are my givens here? Anytime you do a proof, you're always going to start with givens. My givens here are an angle, a side, and an angle. So I'm showing that angle A is congruent to angle Z. Side AB, line segment AB, is congruent to side ZB. And angle ABK is congruent to angle ZBK. Now pause for a second, just kind of run through this visually and make sure you have a good understanding of what we're looking at there. Now that you have a solid understanding of what we're looking at, the next thing we need to deal with is how can we go about proving this? Well, remember, it's a theorem, so we can't just say, oh, it's true. That'd be nice, right? It happens to be true. No, we have to test it somehow. You have to go through this process and actually do a formal process of showing that these two triangles are congruent by using the one thing that we know is true, the postulate. You say, well, how do we know it's true? Because we assumed it to be true. You say, well, how does that work? How can we assume this to be true and then use it to prove something else? Well, if we can't use it in a logical manner, then our assumption was false. It's actually one of the ideas behind logic is we assume an assumption, we use the assumption to prove something. If we can do that, then the original assumption was true. If we can't do that, then the assumption was false. This is the same idea that's used in a lot of science. Okay? So how do we go about doing this? Well, first I constructed the triangle in a very particular fashion to help me. And the next question may be, well, you can do that? You can just design the triangle to look whatever you like? Kind of, yeah. This is geometry. We're drawing it. Draw it the way you want to draw it that makes use of the geometry you have to deal with. Namely, an angle, a side, and an angle is congruent to an angle, a side, and an angle. So I did that. I drew these two congruent, I drew those two congruent, and I've labeled them. And actually what I did is I've labeled them to be congruent as opposed to knowing they are exactly congruent. I don't really care what they actually are. I'm making an assumption here, and this is all based upon theoretical measurements, not real actual measurements. This isn't drawn to scale. And I drew BK to be a shared side between them. So I have my givens. So now what? Well, now I'm going to start listing the things that I know can be true as a result of the drawing or the other givens I have. In this case, I know that BK is congruent to BK. Right? That's actually a reflexive property. So now, look at what we've got there. We got that side congruent to itself. Remember, that's the piece we know is to be true, right? Side, angle, side. Now look what we have. We have a side, an angle, and a side. So now, by side, angle, side, we have a side, an angle, and a second side congruent to each other. Which means by side, angle, side, triangle ABK is congruent to triangle ZBK. Now I always like to put a little box at the end of it to show that I'm done with the proof. In some standard mathematics, you might see the label QED, which is Latin for as was to be shown. And my favorite thing to do is to put BAM because it's fun. Just to designate the end of the proof. It's like putting a period at the end of the sentence, right? Or an exclamation point because you're excited. That's what BAM is. Anyway, so now we have shown that angle-side angle gives us congruent triangles. And so maybe you may be struggling a little bit with, well, yeah, but based on the way we're drawing it, we drew it in such a way that it had to be true. Well, we used side angle side. So what we did here is we used something known to prove something else unknown. And now that we know this other one works, the situation really doesn't matter anymore. We had one scenario that allowed us to be able to prove it in that one scenario. Now we know it's going to be true in lots of other scenarios that are significantly harder to prove. So we don't have to do that because we've done it once already. All right, so there you go. There's that piece. You do the same thing with these others. I'm going to have at least one more video where I do one of these others, and we're also going to talk about side-side angle, and why you can't use that one. But I encourage you to go through and think about ways you can do this. If you're in my class, I actually have one of these others as an assignment for you to work on as well. You can find these everywhere, but I'm going to do at least one more video on some of these. All right, take care.